Welcome to the second part of our lesson on measures of dispersion. Today we shall proceed with measures of dispersion for grouped data. In our last class, we started with the range for grouped data, the interquartile range and the semi-interquartile range and so on. So today we shall look into the range, the interquartile range and the semi-interquartile range, but this time around we talk about it for group data. To start with, look at the following table. This table contains the text scores of 22 students in an Arabic test for beginners. We have it this way: test score, okay, then we have number of students, okay. So we have those who scored 4, there are just 2 of them, and those who scored 6, there are just 5 of them. Those who scored 8, there are just again 5 of them. Those who scored 10, there are 3 of them, and those who scored 12, there are 2 of them, and only one person scored 14, and then 4 students actually scored 16. So the question is, what is the range of this data set? A way to look at it is you can write this particular data set in full, because this type of data set is actually called discrete grouped data set. Discrete what? Grouped data set. So because it is manageable, it's just a small data set, you can write it in full, then you calculate the range. So the range will be the highest minus the lowest. The highest test score is actually 16, and 4 people scored it, and the lowest test score is actually what? 4. So the range is easy to calculate. Range equals to 16 minus what? Minus 4. And this gives what? 12. Perfect. What about the interquartile range? For the interquartile range, you need to calculate the lower quartile and the upper quartile. That is not also difficult to do, but for you to do that, you may need to write these test scores in full. So you have 2 people scored 4. That means we can write the test score in full as a 4 in 2 places. Then 6 students actually scored 6. That means we can write 6 in how many? 5 people scored 6. We can write 6 in 5 places. And then 5 people scored 8. So we can write 8 again in 5 places. Okay? Then 3 people scored 10. So we write 10 in 3 places. 12 people scored 12. We have 12 in 2 places. Only one person scored 14. And then 4 people scored 16. So we write 16 in 4 places. So this data set that we have it grouped discrete, now it is now written in full. So with this, we can now calculate the lower quartile and then the upper quartile. Remember, the lower quartile Q1 is nothing but the median, the median of the lower half of the median. So you need to start with the median first, okay? When you start with the median, you look for the median. So we can cross front and back. Can do like this, okay? Can do like this, and then can do like to get the median. And if you like, can do it one after the other, is okay, because this data is already arranged. Now we are left with only 2. Can you see that? 8 and 8. So the median is 8 plus 8 divided by 2, and that will give us 16. So in essence, the median is actually here. It divides data set into two equal halves. Okay? So having said that, we have got the median. So the lower half is from 4 to this 8 before the red line, and the upper half is from 8 to 16. So the median of the lower half, okay, you also calculate the median of the lower half to get Q1, all right? So the median of the lower half, you can also cross that from here, and cross till 2 if you like. to make it faster. And can you see that? So we have 6 to be the median of the lower half. And so therefore our Q1 is nothing but 6. What about our Q3? Is the median of the upper half from 8 to 16. We also cross this. Okay. And so we have our median to be 12. So the Q3 is nothing but 12. So with this, we can now get our interquartile range to be Q3 minus Q1. And this gives what? 12 minus 6. Okay, and this gives what? 6. And for semi-interquartile range, it's just interquartile range divided by 2. I mean semi-interquartile range equals to interquartile range divided by 2. This is a 6 divided by 2, and this gives what? 3. Yep, can you see that? So for discrete grouped data, you can write it in full. But what if you cannot write it in full? The data set, or you can write it, but it's going to take a lot of space on your booklet. You are having like data of students up to like 100 or even 200, as the case may be. So it will be difficult to write in full. So you need a formula to estimate. Or at times when the data is not discrete but continuous, where you have intervals being grouped. For instance, where you have, as in our example, we're going to see shortly, where the data are grouped. So it's not discrete any longer, now it is continuous. So for we to calculate the range or the interquartile range, the semi-interquartile range as the case may be, we need to estimate it with a formula. Okay, and that is what we shall talk about today. So that formula for estimating the interquartile range, the semi-interquartile range, it is actually a formula that relies on quartiles. Because remember, before you can get interquartile range, you need to get Q1, you need to get Q3. So you need a formula for quartile, but we are not going to talk about quartile alone. Rather, we group 3 main divisions or partitions together, which we call the quartiles, the deciles, okay, and the what? Percentile. Okay, the percentiles. The quartile is from quartile 1/4, and the deciles is from decimal 1/10, and the percentile is what? Percentile from percent, then 1/100. So if we call the quartile, we call it Q subscript I. The decile I will explain DI, and the percentile I explain PI. What is this by definition? QI over here is for the quartile, and I, it ranges from 1 to 4, because it divides into 4. I is 1, can be 1, 2, 3, or 4. Then the decile, I for decile, it ranges from 1 to 10, where I for percentile, it ranges from 1 to 100. So the general formula for computing the quartile, the decile, and the percentile all together is given by this: L plus, in bracket, Kn minus CF divided by F multiplied by W. So what does L stand for? L is nothing but lower class limits of the location of interest. L is what? L is a lower class limit of the location of interest. Lower class limit. Why for K? You see this K, it can take it can take 3 different values depending on what you are calculating. If we are dealing with quartile, k is I over 4 for quartile. For quartile, k is I over 4. While for decile, it is I divided by 10 for deciles. And for percentile, it is I divided by 100 for what? For percentiles. Okay? We've got k. What about n? N is nothing but the number of observations. N is what? Number of observations. Okay? Then you talk about CF. CF is a cumulative frequency. But of what? Cumulative frequency of the class before the location of interest. Of the class before the location of what? Of interest. Cumulative frequency is the cumulative, CF is the cumulative frequency of the class before the location of interest. And F is the frequency, while W is the class width. W is what? The class width. Okay, so now let's see this particular formula in action. Or if you like, we can use it, or we can start with the estimation of the quartiles for this particular data set. I mean the discrete data set. Okay, remember, this formula will only do something for you, and that thing is that it is going to estimate. It's going to estimate the value of interest. Okay, all right. So let us start with the Q1. For instance, I want to use this data set, my test score, and I want to get the Q1, the lower quartile, and I also want to get the Q3, the upper quartile, so as I can get the interquartile range. So for you to do that, you need to set up a table. The test score, you can call it X if you like. We have 4, 6. I'm reading directly from the previous table. 8, 10, 12, 14, and then 16. What about the number of students? The number of students. So where you have it to be frequency. So we have 2, 5, 3, okay, 2, 1, 4. What you need a class limit. Remember, this is funny a little bit because it's discrete. There is no interval there. So the class limit, in fact, we need the lower class limit. Okay, we need the lower class limit. Lower class limit. So for test score of 4, the lower class limit will be 3.5. Then we have 5.5. You were taught this in the previous classes. 7.5, 9.5, 11.5, 13.5, and then 15.5. And lastly, you need the CF, the cumulative frequency. So the first over there, this letter is arranged so we don't have problem. If it is not in order, we have to order it. So we have 2 is the first one. Then the next one is 5. So it's a 5 plus this 2, you get 7. So the CF for the 6th test score is 7. While for the 8th test score is a 5 plus 7, you get 12. Plus 3, you get 15. Plus 2, you get 17. Plus 1, you get 18. And then plus 4, you get 22, which is the total number of students. Perfect. So now we need to apply our formula. Okay, this is our formula for quartile. Okay, so remember the formula for quartile QI. Now it is going to be the lower class limit of the location of interest plus, open a bracket, 1 minute, open a bracket, Kn. We need to know that K is I over 4, and the N is the number of observation, Kn. We shall look at this, minus the CF, okay, divided by the frequency multiplied by the width. So I over 4 for Q1, I is 1. So I over 4 will be 1 over 4 multiplied by the number of observation, which is 22. And this gives 11 over 2, which is equal to 5.5. Okay? Good. So 5.5 is actually the location of interest for Q1. And what that means, we need to get the location itself. This is the cumulative frequency of the location of interest. So when you now take this 5.5, you take it back to the CF table, you can see that 5.5, it is greater than 2, but less than 7. So 5.5 actually falls within this interval. Let us have the color to paint that like this. So 5.5, it is here because the location of interest is actually here, where we have this cumulative frequency to be 7. Okay, 5.5 is in that particular region. So Q1, we have the location of interest. Good. Since we have got the location of interest, then things becomes easier. So our Q1 from here, let's go back to white pen. Our Q1 from here, Q1 will now be the lower class limit of the location of interest. This is 5.5, lower class limit, 5.5. Plus, open a bracket, I over 4 times n, we've got it to also be 5.5, minus CF, the cumulative frequency of the class before the location of interest. So that is the cumulative frequency, that is 2 before the class. So that's going to be 2 here, divided by the frequency of the location of interest, which is 5. Then multiply by the width. Because this is just discrete, the width is what? Is 1. Okay, so our Q1 will be 5.5 plus 5.5 minus 2, that is 3.5. Then 3.5 divided by 5, we get to be 0.7. 0.7. So when you add this together, we get what? 6.2. So Q1 equals to what? 6.2. Remember that we've got Q1 before, earlier on, for this particular data set, and we got to be what? To be 6. So this is an estimation. So it gives the Q1 to be 6.2. When you take this to discrete, it's going to be 6. But let us keep it as 6.2. So let's proceed now with Q3. So our Q3, by definition, we are using this formula for Q3. Instead of saying our Q3, let's just write for Q3. So our I over 4 multiplied by n will now be 3 over 4 multiplied by n. N is 22 multiplied by n. So this will be 3 times 11 divided by 2. 33 over 2. And this gives what? Tell me. This gives 26.5. 16.5, sorry. 16.5. So this is our the cumulative frequency of the location of interest. So when I go back to the table, the cumulative frequency, which is a 16.5 of the location of interest, you see it is greater than 15, but it's less than what? 17. So for Q3, the location of interest is here. Let us change the color as we did before, but this time around, I'm picking a different color. So for Q3, the location of interest is here. Good. If we have got this correctly, then things becomes easier. So now we can go straight to compute our Q3. Okay. So Q3 will now be the lower class limit of the location of interest is 11.5. Do you see that? Plus, open a bracket, Kn. Our Kn, we have got it to be 16.5 minus cumulative frequency of the class before the Kn. Cumulative frequency of the class before the location of interest, that is 15. Perfect. Divided by the frequency of the location of interest. In this case, it is 2. Multiplied by the width, which is 1. Because this is a discrete. The width is always what? 1. So this equals to 11.5 plus 16.5 minus 15.5. You get 1.5 divided by 2 multiplied by 1. That will still be 1.5. So we get this to be 11.5 plus 0.75. Okay, 11.5 plus 0.75. Can you add that together? You get what? 12.25. So our Q3 is what? 12.25. Let us now go back and cross check. The last time we got Q3, we got to be 12 discrete, and we have estimated it to be 12.25. So we are in line. So interquartile range IQR will now be equals to Q3 minus Q1, and this will be 12.25 minus 16.5. Okay, 12.25, sorry, minus 6.2, right? Minus Q1, that is a 6.2. So we get this to be 6.05. 6.05. So when you run this up to the nearest whole number, it is discrete. So you have your IQR to be equals to 6. Perfect, which is what we have got before. If I'm not mistaken, yeah? We have got it to be 6 before. Interquartile range is what? 6. So we can go on to get the semi-interquartile range, and then you'll be fine. Okay? But what about when you have continuous data set? You consider this data set, which I gave you in the exercise of the last class. I didn't share it through this video, so for those of you who attend the class physically, you should have the exercise with you, or maybe later on we can post the lesson notes and attach the link to this particular video. All right, so the data, the table 2, which is our next data which I consider, contains the age distribution of students in adult lesson class. There is an adult lesson class, and the teacher wants to do something with the age distribution of the student. Then we have it. Age group, we have 25 to 29. We have 30 to 34 in years, of course. 35 to 39, 40 to 44, then 45 to 49. Then we have number of students in each of this age group. Number of students. Here we have only 2, the adult class, 3, 7, 5, and here we have 3. So the question is, calculate the interquartile range using our formula. Or we can even make it more explicit. You can calculate the first quartile, or is it the third quartile, the fifth deciles, and the 75 percentile? Then after, we can use the data to calculate the interquartile range and move on. Anyone, as the case may be, you can do that. Okay? So for you to calculate the quartiles, the percentiles, and the deciles, anyone, you need to make a table, the frequency distribution table. So in this case, we can rewrite this table and construct it like we have age group. We can call it X. So we have X, it ranges from 25 to 29, 30 to 34, 35 to 39, 40 to 44, then 45 to 49. Then the frequency. For the frequency, we have 2. Can make a line. You have 2, 3, 7, 5, 3. But you also need the class mark, or the class limit. In this case, we call it the class limit. Not only the lower, you can include the upper. So you have 24.5 up to 29.5, 29.5 up to 34.5, 34.5 up to 39.5, 39.5 up to 44.5, 44.5 up to 49.5. This is our class limit. And then we also need the cumulative frequency. The cumulative frequency, CF. Okay, so we have 2, then 2 plus 3, you get 5, 5 plus 7, you get 12, 12 plus 5, you get 17, 17 plus 3, you get what? 20. Perfect. So with this frequency distribution table, we can warm up ourselves by calculating Q3, the third quartiles, the fifth deciles, and the 75 percentiles for this Arabic data set. So let's start with Q3. Q3, okay, do you still remember our formula? Recall, I can bring the formula here for Q, I, or for DI, or for PI, any one of them. You have the formula to be L plus Kn minus Cf over F multiplied by W. Perfect. So for Q3, we need, the third quartile, the upper quartile. So we need to start with the Kn. All right? For Q3, Kn for Q3, Kn or K, you can start with the K. What is K? Or for Kn, anyone. So this is going to be K, because it's Q3, is going to be 3 over 4, then multiply by N. Your N is total number of observation, that is 20 in this case, the last CF. So 20. And this will give you what? Tell me. 3 multiplied by 5. So this is 15. So this Kn actually gives you the frequency distribution of the location of interest. Okay? So the cumulative frequency of the location of interest. So what is that? If you look at this, the location of interest will now be where? Tell me. Will it be 35 to 39 or 40 to 44? Have a chance to think about this. Okay? Your guess is as good as mine. It is going to be from 40 to 44 age group. Why? It is because 15 is greater than 12. But it is less than 17. So when you continue to count from 12, 13, 14, 15, 16, 17, you will fall into this location, into this interval, this age group. So therefore, for Q3, our location of interest is here. Perfect. Since we have got the location of interest, then everything becomes easy. Just look and say. Look at now. For Q3, you can change our color back to white. So for Q3, we now have it to be lower class limits of the location of interest. Our location of interest is 40 to 44. The lower class limit there is what? 39.5. 39.5. Okay, plus, open a bracket, Kn, our Kn is 15, minus Cf, cumulative frequency of the class before the location of interest, that is 12. Perfect. Divided by frequency of the location of interest, in this case it is what? 5. And then multiply by the width. Yeah, so what is now the width? It is no longer 1. Okay, you can get the width using two methods. The first method could be you just make continuous counting. 40 to 44 is our interval. So when you make continuous counting, you count 40, 41, 42, 43, 44. In this case, you will get 5. Or alternatively, you can subtract the upper limit from the lower limit and the upper class boundary from the lower class boundary. The upper class boundary is what? 44.5. The minus 39.5, you get 5. So our width is nothing but what? But 5. So you can simplify this calculation, and then you have 39.5 plus 15 minus 2. You can say 5 here. Sorry about that. 5 here, we take here 5 here. Then 15 minus 12, you get what? You get 3. So when you add 39.5 plus 3, you get what? 42.5. So your Q3 is actually, your third quartile is 42.5. You can use this method to calculate Q1, and then from there you can calculate your interquartile range, semi-interquartile range, and so on. All right, but now the question says we should calculate the 5th decile. The 5th what? Decile. For 5th decile, that is D what? D5. What is Kn? Remember, the K for decile is I over 10. Our I in this case is what? Is 5. So Kn will be 5 divided by 10, then multiply by n, your number of observation, which is what? 20, sorry. So, and then this will be half of 20. So that will be what? 10. Okay? You got your 10 by saying Kn equals to 1 over 2 multiplied by 20, which is equals to 10. Okay. I want to call your attention to something. Kn is half, even though it is 5th decile, but it is half. That is half of your full data set. Does this ring a bell? Half of your data set is nothing but the median. Thank you. So therefore, the 5th decile will give you the median. Let me come back with this. I said, when you compute Kn for the 5th decile, the K there is 5 over 10, and that will give you half. And that half, you are multiplying it by the whole of your observation. That is, you are dividing your observation into 2. And what divides your observation into 2 is nothing but the median. So therefore, D5 is equivalent to the median. Okay? Perfect. Let's keep it at that. What about Q2? Do you make the connection? Q2. If it is Q2 is I over 4, that will be 2 over 4. And 2 over 4 is half. So that means Q2 is nothing but your median. Can you make it for percentile? Hold it a little bit. Let's get there. All right. Or you can just make it. For percentile, it's going to be the 50th percentile, P50. Because 50 over 100 will give you half. So the 50th percentile or P50 will give you the median of your data set. Even though we are calculating D5 now, we know we are invariably looking for the median for this data set. Good. So now we have got the cumulative frequency of the location of interest. Okay, that is Kn, which is 10. If we now go back to our table, 10 falls in which range? It falls directly in the range before that of Q3. Okay, let's change the color. Yeah, I can pick this one. So our D5, here is the location. Here is the location of what? D5. So if you have got the location, then everything becomes easy. D5 equals to the lower class limit of the location of interest. In this case, it's going to be 34.5. 34.5 plus, open a bracket, Kn. Our Kn is 10 minus cumulative frequency of the class before the location of what? Of interest. The class before the location of interest, the cumulative frequency is what now? 5. So this is going to be 10 minus 5. Divided by the frequency of the location of interest. The frequency there is what? 7. Perfect. 7 multiplied by the class width, which is equals to 5. Okay, because it has equal class width. So now we have this to be 34.5 plus 10 minus 5. That will give you what? 5 times 5 divided by 7. So this gives 34.5. 34.5 plus 5 times 5 will give you 25. And when you divide 25 by 7, tell me, what do you get? 3.75. 3.57, sorry. 3.57. Okay, so when you add this together, 34.5 plus 3.57, that gives 38. Okay, 38.07. 38.07. So your D5 is what? 38.07, which is actually your median. Okay, now we have got this. So again, we need to calculate the 75 percentile. Another correction is coming. For 75 percentile, for P75, what is Kn? Remember, for percentile, K is high over 100. In this case, our I is 75. So it is going to be 75 divided by 100 multiplied by N, which is what? 20. And what is 75? We can simplify this to get what? 25 in 75 is 3, and then 25 in 100 is 4, multiplied by 20. Oh, then a little bit. What do you get here? 3 over 4. Check your Q3. For Kn, it is 3 over 4 times. So that means P75 is equivalent to Q3. P75 is equivalent to what? Q3. In fact, we don't need to make further calculation, because once you see this, Kn is 3 over 4 multiplied by 20. Here we have Kn equals to 3 over 4 multiplied by 20. When you simplify this, you get 15. And then you continue with the process. You locate where the cumulative frequency of 15th falls. So you find that it is here in 17, and so everything will be the same as Q3. Why? Because P75 equals to what? Q3. Amazing. So what we are saying in essence is that Q2 equals to D5 equals to P50 and equals to your median. Okay, Q2. And again, Q3 equals to what? P75. And in fact, Q1 equals to P25. This is a connection we can make. Okay? So because we have got for P75 equals to Q3, we don't need to bother. So for Q1 now, let me just add another question that calculate P25 so that we also use this P of a thing. Okay? So what is P25? So for P25, what is Kn? Kn will be I over 100. This time around 25 over 100. Multiply by n. Your n is what? 20. So this is 1 over 4 multiplied by what? 20. And what do you get? You get what? 5. So the cumulative frequency, okay? The cumulative frequency of what? Of the location of interest is what? Is 5. Okay? Or it falls here. The location of interest, this 5 tell us that it falls in that cumulative frequency that carries it. So let's go to CF. Oh, exactly 5. We have it here. So let me pick another color. This time around, I'm picking red. So the location of interest for P25 is actually this guy. For P25. Okay? So now, I've got the location of interest. Everything becomes easy. So my P25, let me go back to my white column. My P25 will be lower class limit of the location of interest. The lower class limit of the location of interest is 29.5. Thank you. 29.5 plus Kn. My Kn is 5 minus cumulative frequency before the location of interest. Cumulative frequency because before the location of interest is what? Is 2. Before the location of interest, cumulative frequency is 2. Divided by frequency of the location of interest. Go back to your table. Frequency of the location of interest is what? 3. Frequency of the location of interest equals to 3. Multiply by the class width. That is 5 because the width is equal for all the intervals. So you have 29.5 plus 2 over 3 because 5 minus 2 will give you 3. So 3 over 3 will be 1. So this is just plus 5. Perfect. And so this will be what? 24.5. So your P25 equals to what? 24.5. Can you not get in the interquartile range? Yes, we can. Because we have our D3, we have our Q3, and then we have our Q1, which is equal to P25. So interquartile range, Q3 minus Q1. Our Q3, look at it over here. Where is it? Here. 42.5. 42.5 minus Q1, which is what? 24.5. Q1, okay, which is P25. So 42.5 minus 24.5, we get exactly what? 18. So our interquartile range for Arabic data set is 18. What about semi-interquartile range? Semi-interquartile range. So that will be 18 divided by 2, and this will be what? 9.